Hello and welcome to the Aggregated Trades demonstration using the Temporal Relational Extension. If you have any questions about or comments about this presentation, then you can email me at tredatabase@gmail.com. Before we move into the demonstration, I'd just like to point out a few of the concepts behind TRE. We begin by looking at the business data that we want to model. If we factor away the time from the data, we are left with a current view model of the data. This is the model that we develop in. The only thing that TRE demands over and above the current view is that we tell TRE what the time is before we perform our operation. Before we perform an insert, update or delete, we just set the time. All the operations that we perform in the current view are completely audited with a full bitemporal audit that we can go back to view at a later time. This is all done with complete referential integrity at all times. The demo that we've chosen to show today is a fairly straightforward schema. It's a current view schema which includes the trades, a trade ID, a quantity and a price. Trades are for a security, and once a certain number of trades have been received, an aggregate trade is received from the clearinghouse which covers the value of the trades already received during that day. Now moving on to the demonstration, you can see that I've already connected to an XE database. I'm now going to run a script and describe the script to you as we go along. This script is going to perform current view operations on the schema that you've just seen, the securities trades aggregate schema. And we've set up some, before we begin the actual script, we're going to just set up a few script variables so that we can record the transaction timestamp at certain points throughout the script, so that we can go back to them when we show the bitemporal audit at the end of the script. So for example, we have the before any trades, before an aggregate, after an aggregate, before a cancellation of a trade, after the cancellation of a trade, and so on. We also have some script variables to hold the valid time values of the current view operations that we're going to perform. So for example, the trade 1 is going to be performed at valid time 9:30 on the 16th of March, trade 10, 17th of March at 10 past 4. We're going to aggregate at 4 o'clock on the 16th and at 4 o'clock on the 17th of March, and we're going to report on at 5 o'clock on those 2 days. The first thing that we do is we get TRE to generate a temporal version of the current view design that we have. Once we've generated the temporal schema, we have a view for every table in that schema. So for example, we have a securities view, an aggregates view and a trades view. They are showing the same rows that the original current view design had. Additionally, for every view we get an underscore Z view. I'm showing the trades underscore Z view here. The difference between trades and trade Z is that we get 4 extra columns presented to us: YTS, which is the transaction timestamp, start of existence SOE, start of valid SOV, and end of existence EOE. These extra 4 timestamps are there for presentation only. They're useful to be able to show in select statements, but the developer doesn't actually maintain these values. These are values that are managed and maintained by TRE, and you can use them for presentation in SQL statements should you wish. As I mentioned in the earlier presentation, TRE needs to know what the time is before we do an operation, so we'll initially set the time to now, and we have 2 dimensions of time. We have the valid time, which is the modelled time that we are recording, and the transaction time is the actual physical transaction time of the database that we're using right now. So we begin with an empty database. We have no rows in the securities, trades or aggregates table, and we begin by putting lookup data into our security tables. So our lookup data, we've decided, is going to start at a valid time of start security, VT start security, so we tell TRE that the time is that time by using the set valid time function, and we insert 4 securities. We now have 4 securities in the securities table. We're now going to make a quick record of the actual transaction time on this physical database, and we're going to put that time into the before any trades script variable, so that we can go back to it when we're showing the bitemporal audit later on in the script. We're now going to start putting trades into the system in their correct chronological order. The first trade, we receive the first trade at VT trade 1. We insert into the trades table. You'll notice that the insert statement is a current view insert statement. We've just set the time for TRE with the set valid time, and then we've run the current view statement. Similarly for trade 2 and trade 3. If we now run the select statement to see what's in the database at the time, right now we see that there are 3 trades. The first trade at 9:30, the second trade at 11:30, and the third trade at 2:05. You can see that the select statement, though, is a current view select statement. It's a union between the trades and securities table joined together and the aggregates table. We've done no aggregates so far. The reason we have a union is just because our choice of modelling was that we had 2 separate tables, one for the trades, one for the aggregates, and therefore we have to union the 2 together to get the result. That was just our modelling choice, though. So before we're just going to make another transaction timestamp copy before we aggregate those 3 trades. And at 4 PM at VT aggregate 1, we now receive the aggregate record from the clearinghouse. It represents the net value of all the trades that we've received so far, which are trades 1, 2 and 3. And the business functionality dictates that once we receive an aggregate, we delete the trades that we have received that are in the system. In this case, 3 trades are deleted. If we now run the report, we can see that those 3 trades have gone, and there's 1 row for the aggregate. It's the same SQL statement that we used before, just at a different time. We're now going to just take a quick transaction timestamp of the point just after we did that aggregate, so that we can come back to it at a later point in the script. We receive a 4th trade after the aggregate. And if we run the report again, this time at the valid time of the report, 5 p.m, we can see that we've got one aggregate and one trade that happened at 16:05. The time of this report is actually 5 p.m. If we now carry on, and we'll receive more trades after the 5 p.m. report time, the fifth trade. If we run the report again at the time of the fifth trade, we can see that we've got one aggregate and two trades, trades 4 and trade 5. Record another timestamp. This time we're going to show how to cancel a trade. The business functionality of cancelling a trade is simply moving to the start time of that trade, in this case trade 4, and deleting the trade, which removes it from existence in our history. You'll notice that we delete from the trades where the trade ID is 4, and we have these additional 4 lines which checks to see whether that trade has an end of existence. What we see here is that the delete succeeds, which means that trade 4 does not have an end of existence, and that means that trade 4 is not part of a subsequent aggregate. If we run the report again at trade VT report 1 at 5 p.m, we can see that we still just have one aggregate, but now trade 4 has been removed. Trade 5 is not available at this valid time. If you remember, the report is at 5 p.m, but the fifth trade occurred after 5 p.m, so the current status of the system is that one aggregate exists and trade 4 has been cancelled. If we now just take another quick timestamp, transaction timestamp of the time just after we cancel trade 4, we'll be able to come back to that later on in the script. We also show that we use this end of existence to decide whether a trade is part of an aggregate, and if it is part of an aggregate, we will not allow the trade to be cancelled. So for example, if we try and cancel trade 3, we move to the start time of trade 3 and run the same delete statement. This time trade 3 is part of the first aggregate, therefore its end of existence has a value, and therefore we're not allowed to cancel trade 3. If we go back to the valid time of the report at 5 p.m, we see that this is the truth. We have one aggregate, it has the same value, it includes trade 3 because we weren't allowed to cancel that trade. We move on to the next day's trading, and in the next day we're going to receive trades 6, 7 and 9, and trade 8 is not going to be received because it's going to be received as a late trade sometime much later during the day. So we will just run insert trade 6 at the valid time of trade 6, trade 7 and trade 9. If we run the report at the time of trade 9, we see that we've got one aggregate and 4 trades. The fifth trade that occurred after 5 p.m. on the first day, and the 3 trades that we've just received today. We are now going to aggregate. We now receive an aggregate for the second day. So just before we process the aggregate, we'll create a transaction timestamp, and we'll process the aggregate again in the same way as we did last time. Processing an aggregate means going to the start time of the aggregate, inserting the aggregate, and deleting all the trades that exist in the system. This time we've deleted 4 trades because we haven't actually received trade 8 yet. Physically we haven't received it, so there's only 5, 6, 7 and 9 in the system. If we run the report at this time, you can see that at the time of the aggregate, you can see that now we have 2 aggregates. The trades 5, 6, 7 and 9 have been removed, and we've just got 2 aggregates in the system. If we make another transaction timestamp just after we did the aggregate, so we can go back to this time later in the script, we now process one final trade, trade 10, and we run the report at 5 PM on the second day. We can see that we have 2 aggregates and 1 trade, trade 10, happening at 10 past 4. Again, make another transaction timestamp just before we receive the late trade. So as you probably can remember, we've received all 10 trades except for trade 8, and sometime well after 5 PM on the second day we're now going to receive the 8th trade, that late trade. Trade 8 was actually traded at 1500 hours. We only received it at a much later transaction time. So when we finally do receive trade 8, we process it in exactly the same way as we've processed all the other trades. We set the valid time to the time of trade 8 and insert the trade. One final thing we have to do is that we have to make sure that when we do receive a trade, there are no subsequent aggregates, because if there was a subsequent aggregate at a later valid time, then the trade that we've just inserted would have been included in that aggregate. And in this case, because it's a late trade, trade 8 should have indeed been included in the second aggregate, and therefore we have to run the delete trades command again at the time of the aggregate to clean up trade 8. So when we receive a late trade, we actually insert it, go to the valid time of any subsequent aggregate, and then delete it. If we now run the report at 5 PM, we can see that the report is still correct. We've got 2 aggregates and trade 10, and trade 8 has been slotted into the second aggregate that had assumed that we'd already received trade 8, and therefore the value has not changed. If we make a quick transaction timestamp just after the late trade, we can now see that if we run the report at the 5 PM on the second day, this is the current state of the system: 2 trades, 2 aggregates, and 1 trade that's not been aggregated yet. We're now going to show that we can also override the rule that we cannot cancel a trade that is included in an aggregate by cancelling trade 6. So we'll make a transaction timestamp just before we did the cancellation of trade 6, and we will now cancel trade 6. This is an override to the standard functionality. In order to cancel a trade, we just go to the valid time start of that trade and delete the trade. Because it's an override, we additionally have to search for any the next subsequent valid time aggregate, which is aggregate number 2 for trade 6, and update the value of that aggregate to reflect that we've cancelled trade 8 from the system. In this case, subtracting a cell of 90 times 1, which is the price. If we now run the report at 5 PM on the second day, this time we can see that the second aggregate's value has changed to 160 from a value of 70, to reflect the fact that we've cancelled the trade that was part of the second aggregate. We'll now record a transaction timestamp just after we cancel that, so we can show, when we show the bitemporal audit, we can go back to this point in transaction time. You'll have noticed that we have achieved all that functionality by very straightforward current view DML and select statements. The only thing we've had to do is set the time, or tell TRE what the time is before we do our DML or our selects. You can see that it would be probably a good idea to occasionally we have to do more than one operation, so that that gives us the idea that it probably would be a good idea to have a simple business API on top of TRE. Don't always have to do that, but it might be a good idea to help the developers. And so therefore, when we insert a trade, we need to go to the valid time of the trade, insert the trade, and check if any subsequent aggregates exist. If they do exist, we need to delete the trade that we've just inserted at the time of the subsequent aggregate. As far as inserting aggregates is concerned, we receive the aggregate trade and we always delete all the trades that exist in the system at the time of the aggregate trade. And when we cancel a trade, typically we do not allow a trade to be cancelled if there is a subsequent aggregate, but there would be an override for the occasions when we do want to cancel a trade when there is a subsequent aggregate, and that override would update the value of the subsequent aggregate with the value of the trade that we've just cancelled. So finally, even though we produce quite a sophisticated result from a very straightforward schema using very straightforward DML and select statements or current view, all the result of all that DML has meant that TRE has left us with a complete bitemporal audit of what we've done. To show this, we're just going to move around valid and transaction time and run the select statement for the report at those times. So we begin by going to the transaction time before any trades at the 5 p.m. valid time on the first day, and you can see that at that time there were no trades in the system. Before we did the aggregate on the first day, there were 3 trades in the system. After we did the aggregate, there was an aggregate row, and 3 trades have been that the aggregate is a part of, that the aggregate represents, had been removed. If we go to the time just before we cancelled trade 4, we'd actually inserted trade 4 at 16:05, and the time just after, transaction time just after we cancelled trade 4, the trade 4 had disappeared because we just cancelled it. If you remember, we had a late trade, so if we go to the transaction time just before we'd received the late trade, we can see that at the time of trade 8 we would have received at that point trades 5, 6 and 7, 5 from the previous day and 6 and 7 from that day up to the point of the valid time of trade 8. And at a transaction time just after we'd processed the late trade, but at a valid time of trade 8, you can see that trade 8 had been slotted into the correct chronological position. If we now go to a transaction time before we did the late trade, but at a point in valid time report 2, you'll see that before we did the late trade we had 2 aggregates. The aggregate value was correct at 70. It was representing trades 5, 6, 7 and 9, even though we hadn't received trade 8 at that point. And if we go to a point after we'd processed the late trade at the valid time report 2, you can see that the report is as we expect it to be. Finally, we showed a cancellation of a trade that is part of an aggregate. So at the transaction time before we cancelled the cancelled trade 6, you can see that at a valid time of trade 6, you can see that trade 6 did exist at 9:56. Its value was -90. If we go to the time after we cancelled trade 6 at the time of trade 6, you will see that trade 6 has now been removed. And if we go to a transaction time before we cancelled trade 6, but at the time of the second report at 5 p.m, you can see that before we cancelled trade 6, the second aggregate had a value of 70 before we cancelled the trade, and after we cancelled the trade, the second aggregate had a value change from 70 to 160 to take into account the cancellation of the last trade. That's the end of the demonstration. It was a demonstration of the temporal relational extension. It was a very straightforward schema. It was working in the current view, which we think is the most natural way to work with a relational database. Although we didn't show much about referential integrity, TRE also maintains the complete referential integrity at all points in time, both transaction and valid. All you have to do is work out what your current view is, and as you're working with current view, insert, update and delete operations and select operations, you just have to tell TRE what time it is before you run that operation. It's a very natural and a relational way of working. You get very significant effects with very straightforward development. If you've got any questions or any challenges or any observations about TRE, then we'd like to hear from you. You can email us at tredatabase@gmail.com. Thanks for listening.